Hello Vacho. In our last video we studied about work. Now let's extend further the power, the energy. But before that some basic concept. We have studied in the work part that work done in gravity do not depend on path. Whatever the path you choose, if you go like this or you go like this, the work done is always equal to mgh whatsoever the path you choose. If you take the body to a height h, you go straight, you go this way, you go this way, then work done is always mgh, right? So this concept is related to this. In fact, we have two types of forces. One is called conservative force and another is called non-conservative force. The conservative force are those work done by or against which do not depend on path. And for the example, it is gravitational force. So in fact, gravitational force is a conservative force. That's why work done in gravity do not depend on path. Whose are conservative force? Or we can say how we can find out if a force is conservative or non-conservative. A force will be conservative if direction of force does not change with motion. An object is moving, and a force is acting on this object. If the direction of force always remains same, whatever be the direction of motion, then we say the force is conservative. As in case of gravitational force, the gravitational force is always vertically downward. It is always vertically downward whatsoever be the direction of motion. So that's why the gravitational force is conservative force, right? The other force is non-conservative force. Non-conservative force, simply opposite to that, what is? Work by or against force depend on path. In fact, these are the forces whose direction change with the direction of motion, as in case of friction. Direction of friction depend on direction of motion, because direction of friction is always opposite to direction of motion. So as the direction of motion keep on changing, the direction of friction force is also changing. So the friction force is a non-conservative force, and in the non-conservative force work depend on path, right? So that's why in gravity work done do not depend on path. Hope so this is clear to you. So now let's talk about energies. Energies are available in different forms. The solar energy, the heat energy, the light energy, nuclear energy, you name it, and then you will find there is an energy. So energy is available in different form, sound, light, this, that, but here we are more concerned about the one type of energy, that is called mechanical energy. So right now in this video I am discussing just about the mechanical energy. So mechanical energy is what? mechanical energy. This is energy due to motion or state of object. And let's be more precise, or position of object. Right? So mechanical energy is because of motion or position of energy or is an state of energy. Mechanical energy is further divided in two categories. One is kinetic energy, that is due to motion, and another is potential energy. Due to position and state. So the kinetic energy is due to motion of object. If an object is moving, then it possesses kinetic energy. Kinetic energy is possessed only by the moving object. If object moves in any direction, that doesn't matter, it must have a speed. Doesn't matter what is the displacement, what is the direction of motion, it just have a speed. Then there is kinetic energy. The potential energy is due to position of object or the configuration of object. Potential energy is further divided in two categories. One is called the gravitational potential energy and another is elastic potential energy. We'll discuss this potential energy part later. Let's first discuss the kinetic energy part. So if we talk about kinetic energy, we all know that this is the energy possessed due to motion, and this is given by half mv square. This is given by half mv square, where m is mass of object and v is speed of object. If we try to find out the proof of this, let us consider an object of mass F under the application of a force F is displaced by a distance s, and during this displacement the speed changed from 0 to v. So this force would have done some work on it because the force is applied. So this force will do some work. Whatever is the work done by the force, that will convert into the object as kinetic energy. So kinetic energy acquired by the object is work done by force. So let's calculate the work done by force. How much is work done by force? The work done we know by the formula force into displacement. The force we can write MAS. Let's drop it here. Now, using the equation of motion, v square minus u square is equal to 2as, as u is equal to 0, so v square is equal to 2as, or as is equal to v square. Let me place this value here. If I place this value here, then what I get, W is equal to m, this will be v square by 2, mv square by 2, and by definition this work equals kinetic energy, that is half mv square. So this way we can derive this kinetic energy. Okay, so kinetic energy is nothing. If speed of an object is changing, then definitely a force will be acting over there. That force will be doing some work. That work done by the force will be converted into kinetic energy. Now there is one important theorem that is called work energy theorem, and it's really interesting to know, and I will show you with an example that this theorem is always applicable whatsoever the condition may be. What this work energy theorem says? This work energy theorem says work done on a body, work done on a body equals change in kinetic energy. Means whatever the work we will do on the body, that will convert into kinetic energy. Now there is a question always raised, why not potential energy? Why there is no potential, no change in potential energy by work? According to work energy theorem, whatever the work we will do, that will go into the kinetic energy only. Why it cannot go to the potential energy? So wait for a moment, I will do a question and then I will tell you why the work is not getting converted into potential energy. Why work is converted into kinetic energy, right? So in terms of mathematical expression, we can write half m. If final speed is v and initial speed was u, so the work energy theorem is this. We can easily prove this theorem using the same concept as we derived kinetic energy. Let us consider an object of mass m is moving with the application of force F and it is displaced by a distance s, and let during this period the speed of object change from u to v. So work done by force, that is F into s, we can write this is MAS. Let's mark this equation 1. According to equation of motion, v square minus u square is equal to 2as. So as is equal to v square minus u square by 2. Let's put this value of as in equation 1. So what I get? M v square minus u square by 2, and this was our work energy theorem. Okay. Let's see an example and prove that work is always converted into kinetic energy. Okay. So let me take an example in which potential energy is also changing, but the whole work done will go to the kinetic energy. Imagine this is an object. This object is raised by me slowly to a height h. Right? This is an object. I raise it slowly to a height h. Slowly means it does not acquire the velocity. Right? It is moving. It's basically shifting because of my hand. So it did not acquire the kinetic energy. So work done on this object must be 0, right? And we will prove this. This is the object in my hand of mass m. There is weight of object, and this object is shifted to a height h. Obviously, if object has some weight, so to lift the object, we have to apply a force. So let me apply a force. This. Now, can you tell me how much this force must be? Because I am lifting this object without giving an acceleration. I am not giving any acceleration. Because acceleration is not there, so speed is not changing. Acceleration नहीं है, speed नहीं बढ़ेगी, speed नहीं बदलेगी, speed नहीं बदलेगी तो kinetic energy में कोई change नहीं होगा. So we are in the situation when acceleration is 0. If acceleration is 0, then F should be equal to mg. Right? The force must be equal to weight. Acceleration 0 होने का मतलब होता है net force on the system is 0. Here are only two forces acting on the system. One is F and another is mg. So F should be equal to mg. Now let us find out work done, work on body equals work by F plus work by mg, because there are two forces acting on the system. So both forces will do work. So when we are talking work done on a body means, work done on a body means work done by all the forces acting on the body. So how much is work done by force? The F into H. How much work done by mg? That is minus mg into h. Why it is negative? Why it is negative? Because mg and h are opposite. Because mg and h are opposite. So this work will be negative. How much is F? That is mg. mgh minus mgh. So how much work is done on the object? 0. The work done on object is 0. So change in kinetic energy is 0. And this we know from the very start, the kinetic energy of object is not changing. So kinetic energy doesn't change. So work is not also done. ठीक है ना? काइनेटिक एनर्जी में चेंज नहीं हुआ तो वर्क भी नहीं हुआ. अब क्वेश्चन आता है इसमें पोटेंशियल एनर्जी तो चेंज हो गई. कितनी हो गई? ऑब्जेक्ट की पोटेंशियल एनर्जी इंक्रीज्ड बाय mgh. वो पोटेंशियल एनर्जी कहां से आई? वो पोटेंशियल एनर्जी कहां से आई? सो हमने एक फोर्स लगाया था ऑब्जेक्ट को लिफ्ट करने के लिए. तो वो जो हमने वर्क किया था ऑब्जेक्ट के ऊपर, वर्क ऑब्जेक्ट को लिफ्ट करने में, दैट वर्क इज कन्वर्टेड इनटू पोटेंशियल एनर्जी. सो लेट मी डिस्क्राइब इट क्लियरली, नो नीड टू गेट कंफ्यूज. देयर आर मल्टीपल वर्क्स. वन इज वर्क बाय एफ. One is work by mg and one is work on body. जब हम कोई इंडिविजुअल फोर्स की बात करते हैं तो हम इंडिविजुअल फोर्स से वर्क निकालते हैं, जैसे कि वर्क बाय फोर्स, वर्क बाय वेट, वर्क ऑन बॉडी. राइट? दिस वर्क goes to potential energy. जो हमने वर्क किया that goes to potential energy. ठीक है? सो हमने तो वर्क किया लेकिन बॉडी के ऊपर वर्क नहीं हुआ. क्यों नहीं हुआ? बिकॉज साइमल्टेनियसली देयर इज सम नेगेटिव वर्क. साइमल्टेनियसली देयर इज सम नेगेटिव वर्क एज मच द पॉजिटिव वर्क. तो जितना पॉजिटिव वर्क है उतना ही नेगेटिव वर्क है. तो टोटल वर्क डन ऑन बॉडी इज 0. सो ट्राई टू अंडरस्टैंड. हमने वर्क किया कितना? mgh. लेकिन बॉडी के ऊपर वर्क नहीं हुआ क्योंकि हमारे अलावा एक और फोर्स थी जिसने उसके ऊपर नेगेटिव वर्क किया. दैट्स व्हाई वर्क डन ऑन बॉडी इज 0 एंड दैट इज वाई काइनेटिक एनर्जी में कोई चेंज नहीं हुआ. सो दैट वाज सम डिस्क्रिप्शन अबाउट द वर्क एनर्जी थ्योरम, एंड द वर्क एनर्जी थ्योरम इज ऑलवेज एप्लीकेबल व्हाटसोएवर द कंडीशन मे बी. राइट? The kinetic energy is related to work, that is by work energy theorem. There is also a relation of kinetic energy with the momentum. The relation of kinetic energy with the momentum. नहीं, अरे रुको, मेरे को सब पता है. वो एक्चुअली फ्लो नहीं पढ़ाऊंगा ज़्यादा. हाँ मुझे मालूम है. राइट, चलो चुप करो. So we saw the kinetic energy is half mv square. So if the object has a speed, then it has kinetic energy. The one more thing we know already, that if the object has a speed, then it has momentum also. You know the momentum of body? Momentum we describe by P. Momentum is described as mass into speed. So if a body has speed, it has momentum as well as it has kinetic energy. So let's try to find out if how the kinetic energy and momentum are related to each other. If I write the formula of kinetic energy, that is half mv square. Here is m as well as v. So obviously the kinetic energy is somewhat related to momentum. Let me do one change. Let's multiply and divide the m. Then we get k is equal to half mv square upon m. So we know this mv is what? Momentum. So k is equal to p square upon 2m. So that is the relation between kinetic energy and momentum of body. Remember always, if the object has kinetic energy, that it will definitely have the momentum, or otherwise if the object have momentum, then it will also have the kinetic energy, and both are interrelated to each other by the relation k is equal to p square by 2m. Let's talk about the potential energy. Potential energy is a type of mechanical energy which is divided in two categories. One is called gravitational potential energy. Gravitational potential energy. And the other is elastic potential energy. Elastic potential energy. What is gravitational potential energy? The gravitational potential energy is because of position of object in gravitational field. Because of position of object in gravitational field. हम ऑब्जेक्ट की पोजीशन को ग्रेविटेशनल फील्ड में चेंज करते हैं, ऊपर ले जाते हैं या नीचे ले जाते हैं, तो उसकी ग्रेविटेशनल पोटेंशियल एनर्जी चेंज होती है. सो लेट्स से दिस ग्रेविटेशनल पोटेंशियल एनर्जी इज ड्यू टू पोजीशन इन ग्रेविटी. ग्रेविटी में पोजीशन क्या है? At what height the object is placed, and this we know is given by mgh, where h is the height of object. Right, we'll derive this mgh. Now elastic potential energy. What is elastic potential energy? Whenever we apply a force and the object does not move, or the object does not accelerate, then the object gets deformed. Then object will get deformed. So if we apply a force and that force is deforming an object, or the force is changing the configuration of object, then the work done by force is converted into elastic potential energy. This is also known as energy because of deformation, या energy of deformation. So this is the energy by object due to its configuration, means what is the shape or the size of the object is. So this elastic potential energy depend on the configuration, shape or size of the object, while gravitational potential energy depend on its position in gravity. So elastic potential energy due to configuration. Configuration we means here shape and size of object. Now let's find out why the potential energy is mgh. The gravitational potential energy. Gravitational potential energy of an object. Gravitational potential energy of an object raised to a height is equal to work done by force to raise the object without acceleration. Right? Remember, when we are applying a force and the object is not getting accelerated, then the whole work by the force is converted into the potential energy. So let's suppose an object of mass m having weight mg is raised to height h by application of a force F. As acceleration is 0, so F is equal to mg, and work done by force W is equal to F into h, which is mgh. By definition, this work equals potential energy. So potential energy of object is mgh. Right? So that is what is the gravitational potential energy because of position of object in gravity. If an object is raised to a height h, then its potential energy changed by mgh, which is equal to work done by force to raise the object. Conservation of mechanical energy. Conservation of mechanical energy एक होता है conservation of energy. That is what we say. The energy cannot be destroyed or created, yes, but it can change its form. Here we are talking about conservation of mechanical energy. Mechanical energy में दो energies होती हैं. One is kinetic energy and another is potential energy. So when we talk about conservation of energy, mechanical energy means kinetic energy can be converted into potential energy and potential energy can be converted into kinetic energy. Right? So kinetic energy and potential energy, the sum is constant. The sum of kinetic energy and potential energy remain constant. That means the kinetic energy can be converted into potential energy or the potential energy can be converted into kinetic energy. Let's prove this by just a simple example. Let's see an object of mass m is dropped from a height h. at a certain instance it is at position where it has fall down by a small h. Let's name this position A, B and C. Okay. We have dropped this object from the position A. So if we calculate energy at A, at position A, potential energy is equal to mgh, because the height is h. So potential energy is mgh. The h, which is capital H, because the height is capital H. And kinetic energy at position A is 0. Dropped means initial velocity is 0. So it do not have any kinetic energy at the position A. So total energy is how much? That is mgh, the sum of these two. The sum of these two is total energy at A. Let's mark this equation 1. Now let's find out energy at B. At position B, the object has dropped by a small height h. So there must be some speed of object, let's say vb. And here va, yani velocity at A was 0. And here at C will be some speed, that is vc. So first we need to find out velocity at B. Only then we can find out the kinetic energy at B, right? So using the equation of motion, v square minus u square is equal to 2gh. Velocity at B is vb, initial velocity 0, and it has fall by h. So vb square is equal to 2gh, right? So kinetic energy at B, is equal to half m, and speed कितना आ गया 2gh, half mvb square, so that is mg and small h. And what will be the potential energy at this point? The potential energy at position B, that will depend on what is the height of object. Height of object is h minus h. So this is mg h minus h. And total energy at B, is sum of these two. The sum of these two will be what? mgh. That equation 2. So what we saw, the energy at A and energy at B are same. Let us find out at position C. What happened at position C? At position C, first we need to find out the speed. So speed at position is vc. Using the same equation, this v square minus u square, for motion A to C, vc square minus 0 square is equal to 2gh. So vc square is equal to 2gh. So what will be the kinetic energy at C? The kinetic energy at C is half m, vc square की जगह आ गया 2gh, so that is mgh, And how much is potential energy at C? Because now it is at ground. So total energy at C is sum of the two, and this is also equal to mgh. So energy at every point, whatsoever the position may be, it is at every point the total energy is how much? Mg capital H. So if I describe at this position, kinetic energy 0, potential energy mgh. At this position, kinetic energy mgh and potential energy mg mgh minus h, and at this position kinetic energy is mgh and potential energy is 0. So during this whole process the total energy remains same, but if you will see at the different position, kinetic energy do not remain same and the potential energy do not remain same. The kinetic energy as well as the potential energy keep on changing during the whole process. So in the mechanical energy, the kinetic energy and potential energy are interconvertible. That means the kinetic energy can convert into potential energy and the potential energy can convert into the kinetic energy. Right? Hope so you have understood the conservation of mechanical energy. Consider a mass placed here. It is connected to a spring. You know, a spring can be deformed easily. I apply a force F on the object. The spring gets compressed and the mass shifted to this position. The spring gets compressed and the mass shifted to that position. Now you know, and you can try it on your own. If you apply a force to compress the spring, then you need to do some work. And the spring gets deformed. What do you say? The spring will get deformed because now if the object is here, the spring size has been reduced. The object has been shifted by that much, so spring size has been reduced. So spring is deformed. And how this spring deformed? Because we applied the force. So for the deformation we did some work. That is work done by force applied by us. So this work is stored in the spring as elastic potential energy. Because what we said earlier, the elastic potential energy is energy because of the deformation or because of the shape and size. So some energy is stored in the spring. Now we remove this force. We remove this force. This was the force, and what we did? We removed this force. Now what you say? What will happen? Obviously this object will move forward. And it will move forward and it will move with high velocity. That is the concept we are doing in our daily life at many places. Even the gun and bullet are working on this system. When you place a bullet in the gun, a spring is compressed, and when you apply the trigger, then what happens? That spring apply a force on the bullet and the bullet get the velocity. So as soon as we remove this force, this mass will move. This mass will move and it will not stay here. It will move further and will get some velocity. So what we have done, we did some work by apply force. Force apply की, कुछ work किया. That work get converted into deformation energy or elastic potential energy. Then that elastic potential energy is converted into kinetic energy. So that is the whole conversion of the potential energy into kinetic energy. In the previous example we saw conversion of gravitational potential energy into the kinetic energy. When you drop an object, the object has some potential energy, but as soon as it is coming down, the speed is increasing and the potential energy is getting converted into the kinetic energy. In this example, as the spring open up or it tend to acquire its original shape, the object get velocity and the object acquire some kinetic energy. So this is all about the conservation of mechanical energy. A small topic is left, let's complete that, and then this chapter will be over. As far as theoretically concerned, yes, wait for another video in which we have a lot of numericals related to this chapter. This is power. What is power? Right. In our usual daily life we say, this person has a lot of power. Yeah, इसमें बहुत ज़्यादा power है, उसमें बहुत ज़्यादा power है. So, how we relate the power? The power is rate of doing work. Rate of doing work. If you are doing work faster, then you have more power. If you are doing work slowly, then you have less power. Even though if you are doing the same amount of work. Let us consider a person A is doing 200 joule of work in 20 seconds, and the person B is doing same amount of work in 10 seconds. Then who is more powerful? Obviously the person B is more powerful. So power is not only related to work, it is related to rate of doing work. Means how fast you can do work. As much fast you can do work, that much more power you have. So a device which can do work faster will have greater power, and a device which will do work slower, then that will have lesser power. So by definition, the power is work per unit time. If we see the unit will come as joule per second in MKs or erg per second in CGS. From the definition of work, we know work is force into displacement, and displacement upon time is what? That is equal to V. So power is force into average speed. The power is force into average speed. The unit of power is joule per second or erg per second, and this joule per second is also called as watt. The joule per second is also called as watt. 1 watt is equal to 1 joule per second. So that is about the power. That's all for this chapter.